Ryan here for Encore, Episode 7 of the Build Review series. This Volkswagen Bus Truggy has been my most labor-intensive build so far. Started as a wild idea when I was exploring cab-only bodies for a prototype cantilever build. But of course, creating something exceptional always comes with challenges, but we always welcome them and hope that everything works out in the end. There are a few highlights in this build that I want to share, so let's do a quick review of the bodyworks, my cantilever suspension prototype, and the other components. I wanted a cab-only body for this build, so I can highlight the cantilever suspension, but I didn't want another pickup truck cab, so I was on the lookout for a body that I can chop. And since I've been wanting to build a Volkswagen bus crawler anyway, I've started to entertain the idea. After checking the dimensions of this PlayMobil toy, I already knew that I will run into steering clearance issues. Weight distribution and body mounting were also some of the challenges that obviously came with this build. But the idea was too exciting, and I knew I had to try, so I went for it. Before I could start chopping the body, I had to remove the under chassis and interiors. If you're familiar with PlayMobil, you know that their toys are made with thick, durable plastic. So taking apart this bus to get started with the bodywork already took a few hours. After separating the main body, I started planning carefully. There was no turning back or changing plans once I started cutting. I only had one shot at this, so I had to be sure exactly how to cut it. So to convert this to a double cab, I chopped this part off from the third door until the part where it starts to curve on the corner. Then for the roof, I removed this open part in the middle and adjoined the front and back ends. This is how the chopped parts came together. Then, I glued the panels together using JB plastic weld. After that, I smoothed the seam with polyester putty and sanding, and then coated the body with 1K primer before painting. I modified the lens so I can retrofit these ring lights. The wires are tucked into the interior panel, and this interior panel attaches magnetically to the chassis brace to prevent this heavy cab from sliding down. Then from the sides, the body is mounted via flub RC magnetic sliders for the King Snake chassis. For the truggy cage, I designed this to be detachable. This will allow me to do repairs easily. But more importantly, I can create other beds and cages in the future and swap them around easily without modifying the body. This cage is made from styrene rods and it mounts directly onto the existing holes for the roof rack and the turn signal lamps, and I can do the same for the other beds and cages that I want to make. Here at the back, you may have noticed that I used the rear bumper of the bus on the cage. And here in front, you'll see this light bar and brackets from LGRP, and they are mounted neatly on this cage. I needed a pass-through hole for the wires, so I drilled a hole in here beneath the rail where it's not very visible. I've been wanting to make a cantilever suspension for TRX4M, but I can't seem to find the chassis for it. So when DBRC released this King Snake chassis last year, I knew it had a chance. It had the right mounting holes I need to make a drop-in cantilever suspension, meaning it's not like the SCX24 cantilever chassis from Hard Park RC, where the chassis was made specifically for that suspension system. If you have a King Snake chassis, you should be able to run this cantilever system or just a conventional setup if you want to. So the undying question, what are the advantages of using cantilever suspension Or is there any advantage to begin with? Well, that depends on what you're looking for. For aesthetics, it's cool and it's hard to argue with that. In terms of functionality, that will depend on how the suspension system was designed. For this particular prototype that uses 51mm shocks, it's designed to achieve the same ride height and the same droop as a conventional setup, but with 50% more upward travel for the axle. In this side-by-side comparison, you can see that the shocks are identical. These 51mm shocks have a 12mm stroke, which means that in a conventional setup, the shocks and the axle move up together by 12mm when fully compressed. In this cantilever setup, the shocks still have a 12mm stroke, but the axle movement is increased to 18mm because of the geometry. With the right weight distribution and linkage setup, the additional articulation can be helpful in braking over and side heeling, or simply when just cruising over a rocky terrain. Another benefit that you may get from this cantilever is the more progressive behavior of the springs. They're soft and flexible at ride height, but they become stiffer as you reach full compression. If you've seen episode 51, you'll see a proof of concept for this functionality. This Bustard is obviously heavy, and it has a lot of top and front weight, but you'll see how the cantilever has supported that weight without compromising flexibility. This is just the first prototype, and I'm working closely with DBRC to keep the development going. I have the second prototype on hand, and I'm ready to test it soon. The changes we made for this newer version are mostly for fine-tuning the parts, like this rocker arm and this push rod, and also improving the durability and ease of assembly. This Bustard runs on Furitech Unity, which is a motor and ESC in one. This was originally for my Mini Cooper build, but it was too long to be mounted facing forward. But it made perfect sense to use in this build since the cab is already front heavy. You can simply rotate the base plate of the King Snake if you want to use this motor. I find the power delivery and low speed control of this motor to be somewhat similar with the Cedar plus Python Pro combo, and it was able to handle the weight of the rig without cogging. Since the motor is rear-facing, that left me with some space for the battery. The 300 mAh Trias LiPo from Gens Ace fits perfectly in here. These King Snake high clearance links are from RC Steve, but I made a few adjustments. I angled the rear uppers for clearance, then I replaced the link ends with the angled type for a freer movement. The servo is from Globact. The wires exit at the rear, that's why I use it a lot for my 4M builds. These are Muse Isokinetic axles, and no complaint here as usual. These wheels are from DJ Crawler, and these are Black Label tires from LGRP, stuffed with Flub RC inserts. I might replace the tires and inserts to improve the grip, but I have yet to scout for options. This Bustard weighs as heavy as it looks. It's 802 grams with a front weight bias of 61%. Without the body, this setup weighs only 608 grams, or 58% of the weight is in front. So that's it for this build review. I'll be posting video updates here soon for the Cantilever Prototype version 2. I also have new TRX4M and SCX24 builds in the pipeline, so I hope you can stick around for those. If you want a sneak peek of the projects I'm working on, please follow the Rockstar Crawlers IG account because that's where I usually post build updates. As always, thank you for watching and keep rocking!